Hey everyone, today we're going to discuss about rational functions. So, a rational functions can be written in the form f of x is equal to n of x over d of x, where n of x and d of x are polynomials. So basically, this is a function whose equation is a rational equation. So let's have an example here. F of x is equal to 5 over x minus 3. Its graph looks like this. There. This one and this one as well. So this just expresses one function, which is f of x is equal to 5 over x minus 3. Now, we are going to identify some of its parts. So the first one is the 0. The 0 of a rational function is the value of x of the function that will make the numerator 0 without simultaneously making the denominator equal to 0. Basically, we would like to get a value of x that makes the numerator 0, but the denominator not equal to 0. Take note that not all functions has a 0, rather. And also, in a graph, the zeros is the part of the graph where it hits the x-axis. In our example here, we can observe the graph doesn't hit the x-axis at all. We can see that it approaches the x-axis. It gets closer to the x-axis, to the left side and to the right side as well. However, it will never hit the x-axis. Such line is called an asymptotic line, which we're going to discuss in our next videos. Now, the second is the intercepts. The intercepts are x or y coordinates of the points at which a graph crosses the x-axis and y-axis respectively. The x-intercept is the x-coordinate of the point where the graph crosses the x-axis. So in our graph here, there's no x-intercept because it doesn't intercept the x-axis. The y-intercept, however, is the y-coordinate of the point where the graph crosses the y-axis. In this graph, there is a y-intercept, which is this point. It hits the y-axis. So what we're going to do today is we identify the zeros and the intercepts of the rational function. We can do that by graphing. We can also do that algebraically, which we're going to discuss. So what we'd like to know is the intercepts and the zero. Now, the thing that's convenient here is that whatever your solution for the x-intercept, that is also the zero. So if we solve for the x-intercept, we've also solved for the zero as well. So let's focus more on solving for the x-intercept and the y-intercept. Once we have the x-intercept, we also have the zero as well. So x-intercept, y-intercept. So for the x-intercept, it is represented as a 0, where a is any real number. Therefore, what we're just going to do is to set the value of y as 0, then solve for x. So in this case, the y is represented as f of x. So we're going to replace this f of x as 0, then solve for x. So we'll now have 0 is equal to 5 over x minus 3. Now, next thing that we're going to do is to multiply both sides by x minus 3 so that we can get rid of the denominators. Multiply both sides by x minus 3. So x minus 3 times 0, that would be 0, is equal to, let's divide the numerator and denominator, so we're left with 5. 0 is equal to 5, which we know is not true. We know that 0 is not equal to 5. Therefore, if this happens, we end up with a false statement. We can just conclude that there is no x-intercept. And since there's no x-intercept, there's also no zeros for this function. Now next, let's have the y-intercept. The y-intercept is represented as 0, b. So it hits the x-axis, therefore the value of x is 0. We're just going to replace the value of x as 0. Then solve for y. So we get this, replace x as 0. Therefore, f of 0 is equal to 5 over 0 minus 3. 0 minus 3 is negative 3. Therefore, f of 0 is equal to 5 over negative 3. Or we can just say it as negative 5 thirds. Therefore, our y-intercept is negative 5 over 3, which if you remember earlier, it's in below the x-axis, right? So let's check it out. So let's type it here. F of x is equal to 5 over x minus 3. You remember that the y-intercept is negative 5 thirds, which is over here. Yeah, that's negative 5 thirds. Remember that negative 5 thirds is approximately negative 1.6 repeating. So it's more than negative 1. It's less than negative 1, but more than negative 2. So right here. So that's everything for rational functions. I hope you learned a lot for this discussion, and see you guys on the next video.